Hello and welcome to Prisoner's Trilemma, Game Theory in Action. An introduction. Prisoner's Trilemma is a game about game theory, and it's designed to help you understand its key concepts. The notion of a payout matrix, which plays a central part in game theory, is used in this game. Game theory pervades all games and is the strategy that underpins human interactions. In Prisoner's Trilemma, players consider interesting moral and ethical trilemma situations with multiple possible outcomes. Players choose to cooperate, betray, or compromise, and based on what other players do, an outcome is determined through a payout matrix. It falls into the category of game theoretic games, so this game explores the genre of game theoretic games, which is used to study and understand game theory. So game theory was as a discipline was founded by John von Neumann and Oscar Morgenstern in 1944 with their book Theory of Games and Economic Behavior to study two-person zero-sum games. Today, modern game theory is the science of logical decision-making in humans, animals, and computers through strategic interactions among agents. Game theoretic games include Prisoner's Dilemma, Selton's Chain Store Paradox, Schelling's Solitaire, O'Neill's Card Game, and the Ultimatum Game, among others. Setup and objective. In Prisoner's Trilemma, the objective of the game is that it's a head-to-head game where players or teams try to score points based on the outcomes of their decisions for various trilemmas. Players get points from a payout table based on whether players choose to cooperate, betray, or compromise. The game ends after 5 rounds. Scoring at the end of the game, you add points from all the 5 trilemma phases, and then the value 1 through 8 payout science cards in your score pile are worth 1 point, value 9 through 13 cards are worth 2 points. To start the game, you're going to create teams. This is a head-to-head game. If you're playing with more than 2 players, divide the players into 2 teams. One player is designated player A or PA, and the other player or team is designated player B or PB. You prepare decks. You're going to remove the wild cards from the deck. You're going to strip out the science domain cards to form the payout deck. And then you'll remove from the game, the values 8 through 13 of the technology domain cards. And then you'll shuffle together the remaining cards to form the draw deck. Each player or team draws 13 cards from that common draw deck, and they have their trilemmas ready for use. And we see here visually that you're going to create teams, divide your players into 2 teams. You're going to expel the appropriate cards. You're going to set up the draw deck, set up the payout deck. Remember, those are the science domain cards. And then each player or team is going to draw 13 cards, and you'll have your trilemmas ready for consideration. Gameplay. So here is a diagram of the basic phases in a round. Again, the game is played in 5 rounds. So in the first phase, you're going to draw and select a trilemma to consider for that round. Then there's a trilemma phase, a game theory phase, a game theory score phase, and then you'll check for end of game. In the first phases, each player or team draws 2 cards from the draw deck, and you'll select a trilemma from the trilemmas in the rulebook or from my website, and players will decide on which trilemma to use for that round. In the trilemma phase, players are considering the trilemma with a fixed payout table. If you're playing in teams, players could deliberate before they choose whether to cooperate, defect, or compromise. You'll choose a service domain card to represent cooperating, use a knowledge domain card to defect, choose a technology domain card to compromise, and then play the chosen card face down. You'll reveal cards and consult the trilemma phase payout table, find the cell in the table based on the cards played, and calculate and note the scores. Here is the trilemma phase payout table, and we see along the rows that player B chooses to cooperate in the first row, player B chooses defect in the second row, player B chooses to compromise in the last row. In the first column, player A chooses to cooperate through a service domain card. In the middle column, player A chooses a defect using a knowledge domain card. And in the rightmost column, player A chooses to compromise through the use of a technology domain card. And we see at the intersection of the rows and columns, you read the text to determine what happens and determine points that are scored. And here we see an example of the trilemma phase. So they're considering the prisoner's trilemma, and Player B has chosen to play a technology domain card, the 2 of technology, cloud computing, and player A has chosen to use a service domain card, the construction services, and you'll find the intersection of the player A's cooperate, the leftmost column, and player B's compromise card, the bottommost row. At that intersection, player B is going to get to look at the face down card for the next phase, and player A doesn't score any points. In the next phase, the game theory phase, you're going to consider the same trilemma again, and you're going to reveal a card from the payout deck for the cooperate payout scorecard, another for the defect score card, and then you'll have a third for the compromise payout card, and that will be face down. If necessary, reshuffle the payout discard to form a new payout deck, and players will consider the trilemma that they did in the previous phase, and if playing in teams, players can choose to deliberate. You will then decide whether you want to cooperate, defect, or compromise. You'll choose a service domain card to represent cooperating, choose a knowledge domain card to defect, choose a technology domain card to represent compromising, play the chosen card face down. Then you'll move on to the game theory scoring phase where both players and teams reveal their chosen cards face down. You turn those face up, and then you'll use the game theory payout table to find the cell in the table that's based on the row and column of the revealed player cards. Then follow the instructions in the table cell to claim the payout science scorecards, if any, and discard any unclaimed payout science scorecards. So here we see the game theory phase payout table, again, where on the rows, player B cooperates, defects, or compromises, and in the columns, player A chooses to cooperate, defect, or compromise, and we'll see an example of that. Here, player A chooses to use the transportation services card, the 11 of services, and that represents that player A chooses to cooperate, and player B uses the 7 of knowledge card, and that's shown on the middle row where player B defects. And at the intersection of that row and column, you'll read the text where player B takes the lowest payout scorecard from a player, and player A takes the cooperate payout card. We see that again, they're considering the prisoner's trilemma as their selected trilemma for the round. And we see in the bottom left here that the 7 of science is the cooperate payout card. Notice that it's face up. The 2 of science is the defect payout card, also face up. And the compromise payout card is also a science card, but a scorecard, but it's face down. End of game. The end of game occurs after the 5th game round. Scoring at the end of the game, after the game ends, you'll calculate scores. Add the points earned from all 5 trilemma phases. The value 1 through 8 science cards in your score pile are worth 1 point, and value 9 through 13 cards are worth 2 points. Game theory. In this section, we'll go over some of the key ideas and concepts in game theory, as the idea of Prisoner's Trilemma is to explore some of the key concepts of game theory and to familiarize yourself with game theory. So the 5 key basic concepts of game theory are that there are players, groups of people, consumers, or producers, or decision makers that play a game. And game theory has games, a conflict or cooperation between decision makers with behavioral relationships. Games also have rules, the statements and directions that must be followed within a given game for it to be played correctly. It also has strategies, which is the set of all possible actions that define the behavior of players in a game. Game theory studies strategies players employ based on what rivals do. A dominant strategy is the best strategy for a player irrespective of other players. And then finally, payoffs is the last pivotal concept in that, and that is what players receive from arriving at specific outcomes of a game. The most famous example of game theory is Prisoner's Dilemma. This is where police have caught 2 criminals for a misdemeanor, a minor crime, but they're thought to have committed a much larger, major crime, a felony. And then the police offer a deal to each prisoner separately, so they separate them into 2 separate rooms, and they offer each a deal. If they will betray the other with incriminating testimony, then they'll let them go. However, if they each betray the other, they'll both serve a lot of time in prison. But if they both stay silent, they both cooperate with each other, then they will be convicted of only the minor misdemeanor. They can't be convicted of the felony. So this is a classic example, and it has a canonical payoff matrix and a Nash equilibrium. So we see here the prisoner's dilemma payout table. If player A chooses to cooperate in the left column, or player A chooses to betray in the right column, player B chooses to cooperate in the first row, or player B chooses to betray in the bottom row. So if both choose to cooperate, they can only be convicted of a misdemeanor and only serve 1 year each. If player A betrays and player B cooperates, then player B serves 12 years in prison and player A goes free. If player B betrays and player A cooperates, player A will serve 12 years in prison and player B will go free. If player A and player B both betray and they're both provide incriminating evidence for the other person, they're both convicted of a felony and both serve 10 years each. The concept of a game theory normal form is a normal or strategic form of a game is represented by a payout matrix showing the players the strategies and payoffs that can happen in a game. It can be represented by any function that associates a payoff for each player with every possible combination of actions. So the example below is one of a two-player, two-strategy game where there's two strategies available to each player, and there are two players, player A and player B. And their strategies are shown in the rows and columns. This payoff matrix describes the outcomes of the player's choices with some example numbers. So we see that in the leftmost column, player A can pick strategy 1. In the rightmost column, player A picks strategy 2. In the first row, player B chooses strategy 1, and in the bottom row, player B chooses strategy 2. So in the intersection of where player A picks strategy 1 and player B picks strategy 1, we see the payout is that player A would get 2 points and player B would get 3, and so forth. So you see, for example, if player A picks strategy 2 and player B picks strategy 2, that's the rightmost column, bottom row, and that cell reads payout for player A picking number 2 and player B picking strategy 2. Player A would get a payout of 8 points and player B would get a payout of 9 points. Game theory applications. Today, game theory has been used in computational economics, experimental economics, behavioral economics, and information economics to study auctions, bargaining, pricing, fair division, duopolies, oligopolies, social networks, equilibriums, and voting systems. Game theory has been used in political science for political economy, public choice, war bargaining, positive political theory, and social choice theory. In biology, it's used to study fighting behavior, territoriality, biological altruism, and evolutionary stable strategies. And in computer science, game theory is used to model interactive computations, multi-agent systems, and algorithmic game theory. It's also used in philosophy, the retailing industry, and epidemiology. The tech deck concept. The tech deck has 3 key ideas. It modernizes playing cards, bringing them into the 21st century. You can use it for any classic card game, and unique game effects on each card create interesting interactions and provide replayability. It's versatile. The small form factor is easy to carry wherever you are, whomever you're with, and whenever you like, you can enjoy gaming. Games long and short, casual and serious. The tech deck is a game platform that you can play many games with. They will appeal to different audiences, speaking to hardcore gamers, non-gamers, party settings, and family settings. There have been 12 previous tech deck games released: Tech Grid Poker, Tech City, Tech Exchange, Tech Chess, Gears of Industry, Elevator Pitch, Cardle, Chronological, Peer-to-Peer, Carduku, Newsworthy, and Card Barrage. Tech Grid Poker is a two-dimensional poker where the cards have card abilities, and it's a poker variant game. Tech City is a semi-cooperative tile-laying city-building game, where as you lay out city tiles, you have more effects available to all the players. Tech Exchange explores the real-time genre of games where players exchange cards and representing stocks in real time. Tech Chess is a chess variant game where you can upgrade and build new pieces, and you play a game of chess. Personalized card games are explored in the Years of Industry game, where you customize your deck and play a head-to-head game. Elevator Pitch is a creative party game where players use the cards to create an idea for a company and deliver an elevator pitch to other players. Cardle is a head-to-head code-breaking game. It's a deduction and puzzle genre game. Chronological is an education history-based family and party game. And Peer-to-Peer is a cooperative deck-building game. And Cardoku is a cooperative and head-to-head puzzle-solving game. Newsworthy is a game where you search the internet as a source of conversation, as a conversational game. Card Barrage is a dexterity-based tower defense game. And finally, Prisoner's Trilemma is game theory in action. So thank you for watching this video. I hope you found it useful and gives you a sense of the Prisoner's Trilemma. And be sure to check out my YouTube channel and my website for other resources and rules and videos for how to play the other tech deck games. Thank you.